The next pair of properties I want to talk about are physical properties versus VS chemical properties. Okay. So physical properties, how do I say this? Physical properties, there's no new substances are formed. I'm going to put it this, no new substances. No new substances are formed as you are evaluating that physical property. Here I know in my lecture notes it says something about there's a chemical reaction does not occur, and the definition of a chemical reaction is occurring is that new substances are formed. So no chemical reaction occurs, no new substances are formed. So basically, if you are measuring a physical property, what you start with is what you end with. That's kind of the way I think of it. So physical properties, there's a list here all talking about physical properties. So for instance, I'd like to say no molecules were harmed in the measuring of these properties. Now, of these properties listed here. These are all physical properties. And notice that actually some of them are kind of like tests and some of them are more like observations. Okay, all observations would be, if it's a property, would be a physical property, because in an observation, no new substances are formed. So for instance, color is both an intensive property and it's a physical property. So do you get that? I bet you do. The state of the matter, is it a solid, liquid, or gas? Again, that's no new substances are formed. These are transition temperatures. What temperature does it melt at? What temperature does it boil at? No new substances are formed to measure that property of that matter. Let's see, what else do we have here? Density. You know, the density, and we'll be talking more about density, but density is kind of how packed something is, how packed the mass is in a volume, or how fluffy the mass is kind of in a given volume. So the density of an object, if you're playing 50 questions or 20 questions, the density of an object can help you figure out what that object, what that matter is. These are all properties. The solubility, how much of it will dissolve in usually water, will it conduct electricity? These two kind of go together. Can you make it flat or can you draw it out into a wire? That's ductility. And I have a kind of a little video talking about viscosity. So these are all physical properties. What you start with is what you end with. So a physical property we saw on the previous slide was the boiling point temperature and the melting point temperature, those transition temperatures. So I think this is quite clever. Here, if somebody's, if somebody has these two white powders and they're like, well, which powder is naphthalene and which powder is aspirin? Well, what they're going to do is put it in boiling water. Now we know that that water bath temperature is what? It's 212 degrees Fahrenheit if it's boiling at, or 100 degrees Celsius. So here's the deal. Naphthalene will melt at a lower temperature. Naphthalene melts at under 100 degrees Celsius, and aspirin melts at over 100 degrees Celsius. So that's why you're seeing the naphthalene liquefy and the aspirin stays a solid. So now, just my point here is that this naphthalene over here, it still stays the cute little naphthalene molecules, even though we'll be talking more about what happens when a solid goes to a liquid coming up. But it's still the same molecules. No new substances are formed. So I think that's kind of neat. And then I kind of finish up with, well, that's where color is a physical property. Of course, no new substances are formed when I identify, yellow, sulfur is yellow, malachite is green, and sapphire is that white? I'm not sure. Not sure sapphire is supposed to be white. Okay. So one last, or also listed, was viscosity. Now viscosity is a physical property. No new substances are formed when we see how viscous something is, when we perform a viscosity test. Viscosity is just kind of how runny something is or how stubborn it is to run. So let's see if we can play this little video here.
The viscosity of a liquid depends on the strength of its intermolecular forces. Glycerol has relatively strong intermolecular forces and is rather viscous. Its resistance to flow is high. Ethanol, by contrast, has weaker intermolecular forces. It flows easily and has low viscosity.
Okay, so there again, if you were given two liquids and you wanted to know which was which, you could do a non-destructive test of simply seeing which one's more viscous to know which one's glycerol. So that's kind of how physical properties work.